is all about. Stay there. Three, 2, 45?
45.
Oh! Okay. Come on, little dude. Come on, little dude. There you go. This one, we already talked about a bit. Yeah.
I was going through my old test last night. I saw you draw a skier on the back of my page.
Oh, yeah.
I just noticed it like a tiny little skier in green marker.
Yeah, I like when you guys draw little pictures and stuff. Sometimes I'll add something to it. Yeah. If you draw a face, I'll put a little stick body.
So we're doing, remember what problem again?
45. This one here?
Yeah.
Yeah. So we talked about this one. The idea is when the angle is very small. And again, this is why I kept talking about flat Earth and so forth, is because why does the Earth look flat to us? Because we are right on it, right? How far up do I have to go before I actually see the curvature is quite a bit. Because the curvature is so slight, because the Earth is so damn big. Yes? Okay, I like it. What the hell does that have to do with anything, Jeff? The smaller the angle that I'm looking across, the more flat that side is going to look. So I can approximate the, so for example, is the mast of a boat curved normally? Real quick, one thing that could be a stumbling block on this problem is you might not know what the hell a mast is. So you always got Google, or if you prefer for some crazy reason, Bing, right? You guys all with me, so you can look up what the mast of a boat, but it's basically the thing that the sail comes off of, so it's just a mast. That's why it's so huge, 32 feet high, right? So another thing would be how to draw this. Now you could draw a little boat, to be honest, it's all about the frickin' mast, correct? So I would just draw a mast. And so if I'm looking at it, I look at the top and I look at the bottom, right? And what is this angle here? 2 degrees, 11 minutes, right? Since that's such a small angle, even though this is straight, I can approximate it as if it was the curvature of a circle. You guys all with me so far?
And how come?
Say again?
How come?
Because the angle is so small. So let me do something. This is really good. I'm remembering to do this, and I forgot before. Give me just a moment. I don't want to be there. I want to be here. Let's learn together. Okay. I can't remember this. I think it can handle this. Let's see if it can handle this. Circle. You can see the curvature, correct? Everybody sees it?
Yeah.
Okay. If I go here, what angle am I effectively looking at? What angle is it? 90 degrees, with me? Or how many radians? 5/2. As I zoom in, am I not looking at a smaller and smaller slice, like a smaller and smaller degree? Are you guys with me? What's happening to the graph as I zoom in? In fact, it's already happened. Doesn't it look damn straight? The smaller the angle, and again, if I zoom back out, let's see, is there a way to do this? I don't know if there's a way to do this. As I zoom back out, we were right there, yes? I was just right there. Isn't that a tiny, tiny, tiny angle for the part I was looking at? Are you guys understanding what I'm saying? When I zoomed way in, I was looking at a tiny angle. So the smaller the angle, the more linear it becomes. And you can see that just by zooming in. You don't have to zoom that much. It already looks freaking linear. I didn't zoom in that much. You all agree that it looks, if I would have shown you this, I would expect everybody to go, that's a straight line, right? And if I was a better teacher, I would have done that. I would have started here, and then I would have said, no, it's a circle. All right, too bad for me. Okay, not a good teacher, too bad. So if you zoom in, this is what I keep talking about flat Earth. This is why there are flat earthers. because they can't think beyond their immediate surroundings, right? So, again, what does that have to do with this problem? Is that a very big angle?
No.
Therefore, I can treat this as if it is part of a circle because it would be about linear anyway. So am I going to get the exact right answer? No, but I'm going to get a really good approximation. Yes?
So you said, the it's a curvature?
You agree with me there's a curvature here, right?
Yeah, I'm just asking, like, when you're saying curvature, you just mean like it's round.
Yeah, it's curving. It's not straight.
Yeah.
But if I zoom in enough, it looks as though it's straight.
Mm-hmm.
And the part I really want everybody to understand, does everybody understand I can talk about the angle that I'm looking at? Just watch this as I zoom out. Just keep an eye on when I zoom out. Let me do it this way. See how I'm in this square here? And it looks straight? Ready with me? So if I zoom out, we were in this square here. If I zoom out, zoom out, zoom out, isn't that a really tiny angle if I draw to the edge there? It's a very tiny angle part I was looking at. And it looked straight. So officially, if I want to use the arc length formula, doesn't this have to be curved a part of a circle to use this, correct? If the angle is small, it's okay if this is not curved because it would look flat anyway. It's a really good approximation, especially when this angle is smaller and smaller. Let me stop for a minute.
So are you saying that the reason why we can use the arc length is because we want to find the curvature, right?
The question is not what's the curvature. The question is what's the radius? What's the distance away, right?
Okay.
But this formula only works for what? What is that formula for?
Arc length.
Of a circle, of a piece of a circle, correct? Is a straight mast a part of a circle? No. If I continued it and let it would just be a straight line up and down. But again, if I zoom in on a circle, doesn't that piece look straight? Doesn't it look flat? So I need you to understand, I'm not going to get the exact right answer, but I'm going to be off in like the 15th decimal place. Most of us humans don't care about that. Right? If I said, how far away do you live? And you said 11 miles. I said, no. 11 point what? You say 11.3. No. 15, get away from me. Right? So, real quick. If I kind of pretend like this is a little bit curved, didn't they tell me the arc length? Coming back to the problem.
Yeah.
What was the arc length? The approximate arc length. It's not really curved, but come back to me. Okay. 32 is the arc length. That's going to be 32. That's this piece here. Do I know the angle? Sort of. Because what's it got to be if I want to use this equation? It's got to be in radians because that's the physical measurement. So then the problem really becomes, because the problem is relatively simple. They told me S, they told me theta, I can solve for R. So then the problem really becomes, can you translate that thing into radians? You guys all with me? So if you make that into a decimal degree, you can then turn that into radians by doing pi over 180 times that. Does that make sense?
Yeah.
Okay. And then go ahead and just multiply this shit out. Get a decimal. Right? Okay. We stop for a minute. Okay. So when the angle is really small, even if this thing is not curved, I can still use this formula. Yeah.
Can we go over 3.2 number 70?
Let's see. Oh yeah, this is a good one. I think I told you guys that there is a way to change the angle formula if it's degrees. Yeah. So the area formula. So what is the area formula as given if the angle is in radians? What's the area formula? Just the standard area formula.
1/2 r squared times theta.
Good. And that's assuming this is in radians.
Yeah.
So if this is in radians, how do I change it to be degrees?
I over 180.
No?
180 over 5.
Yeah, I want the radians to cancel, and I want to make it into degrees. You guys kind of with me?
I'm kind of confused. So is it just asking what formula we're supposed to use, or?
So, does everyone agree that this formula requires theta to be in radians?
Yes.
Good. This is telling me, how can I rewrite this formula so it will accept degrees?
Okay.
So really what you're saying is, if that is in degrees, what would I do to it to make it radians? And then you just throw that stuff into the formula. So instead of doing two steps, so real quick, if my angle was 40 degrees, I can't plug that in there, you all agree?
Mm-hmm.
So what would I have to do first?
You have to make it to radians.
Make it to radians. I think I said it backwards just a minute ago, I'm sorry. So how do I change it into radians?
Pi over 180.
Yeah, pi over 180, there it is. Okay. I got it the other way. So instead of doing that on the side and then plugging it in, couldn't I just, for any angle, wouldn't I do the same thing? Wouldn't I do this if it was in degrees? Wouldn't I do this? No matter if it was 40, if it was 67, it was 2028 degrees, you would do this, yes?
Yes.
Mm-hmm.
So couldn't I just take this, I'm basically doing the problem for you, and plug it in there?
So it'd be pi over 180, or like theta pi over 180.
Well, so it'd be theta pi over 180, and then shove that shit in there.
Got it.
Yeah. So really all the problem is saying is, instead of doing two steps, if somebody gives you degrees, can you just give me what the area formula looks like so it does it for you inside, right? So this is what you all agree I would do to make the angle become radians instead of degrees. So just replace this with this.
So we would
And then you
have-
can simplify a little bit.
So when we input, would it look like 40 over 180, and that's how it would give it?
Well, 40 I made up.
Oh.
40's got nothing to do with the problem, right? I just wanted to give us a concrete number so we go, okay, I know how to do that. So no matter what the angle is,
Mhm.
you would do this.
Okay.
So replace this with this. Sort of like, circumference is pi times diameter, correct? What if I knew the radius? In order to use this formula, what would I have to do? If we knew the radius was 5, the formula needs what?
2 times
Diameter. So I would just have to double it, correct? So instead of doing two steps, doubling it and then throwing it in, I could just replace this with 2r. That's all we're doing. So now it accepts radius, doesn't it? Okay, so that's what we're doing here. Instead of doing two steps, take what I would do and shove it in there. Then I got one formula that can accept degrees. Yes?
So if we're going from radians to degrees, shouldn't it be 180?
No, I'm going from degrees to radians.
Oh, in that question also?
Yes.
Oh.
Because it said, where'd it go? Oh, when the angle is in degrees. So if the angle is in degrees, I want to change it to radians. Because again, what does this formula need? The angle has to be in radians. Cool. Okay. That's not a huge deal. But I need you to kind of understand, I can always adjust the formula to accept different inputs. I always can. But it just makes the formulas look a little worse if I do that. Okay. So this is not claiming it's going to be a better formula. It's just, what would it look like if I wanted it based on degrees? Okay. All right, let's just do this. So what am I going to put in place of theta? Because that's in degrees, we're assuming, right? Theta pi.
Over 180.
Come with theta. What's on the bottom? What do you get on the bottom?
360.
So I get r squared pi theta over 360. So that is the area formula if I don't want to change my angle to radians. So let's do this. All right, let's do this. Let me see. So if I had 40 degrees, let's come back to 40. And I have the radius is 10. Let's do it the old-fashioned way. How would I change this to radians?
Pi over 180.
Yeah. These would cancel. I get 2 pi over 9. Is that cool? Okay, and if I throw that in, it'd be 1/2 radius squared times 2 pi over 9. Can somebody do that for me, including multiplying by pi? You got your calculators, anybody? Let's see, what'll that be, Jeff? It's going to be about... it's maybe about 35?
34.9.
Huh? Yeah?
34.
34.9? And I didn't give us any units, so meters, so that would be square meters. Okay, you guys with me so far? That's the way I want you to do it that way. This formula is kind of dumb, which is why it's just a side note in the homework. It's not like a main thing. I don't want to work with that formula, but just to show you. What if I plug all my shit in? Now, what does theta have to be in this formula? It has to be in degrees, the way that I constructed it, correct? So let's put shit in. R is 10. Theta is 40 degrees over 360. So throw all that in your calculator. Smoke it. You should get the exact same number. You should still get 34.9.
Okay, so you're saying that portion towards the end is supposed to help with just putting degrees in, but not.
That's the whole point, yeah. How can I change the formula so it can accept degrees? What I do is, I take the work I would do to make it radians, and I shove that into the formula and make the formula look a lot worse. Y'all agree that formula looks a lot worse?
Yeah.
Okay, I would never use this damn thing then. It's just a little side note. Just a little side note. I could do this to any formula I want to. Real quick, let me show you another example. What's the area of a circle? Pi r squared, right? Just to show you another example. This is a formula you almost never would see. Some of you guys are like, I want to keep it that way. Too bad. I'm going to show it to you. Area is pi r squared. I want an area formula that depends on diameter instead. Because I'm weird. How the shit am I going to do that? Well, what is the radius in terms of the diameter?
1/2 d.
Yeah, it's half a diameter, correct? So normally, if I knew the diameter, I would cut it in half, and then I would shove that number in, correct?
Mm-hmm.
I would do 2 steps. So now, instead of that, I'm just going to shove this whole damn thing in. Pi times d over 2 squared. What's d squared? D squared's crazy. What's 2 squared? 4. That is the area of a circle if I know the diameter. I would rather not memorize a whole different freaking formula. I would rather just freaking cut the diameter in half. Do you understand?
Yeah.
So again, this is a homework problem. This is not a formula I need you to memorize. It's just a little side note saying, hey, I could do this if I wanted to. Same way I could do this. And very quickly, if the diameter was 10, what would the area be from this formula? What would I do first?
Half it.
Good. So then it would be 25 pi. Is that cool?
Yeah.
All right, let's try to use this formula. The diameter's 10.
100.
What's 100 divided by 4?
25.
25. Okay, it's the same stupid answer, just the formula looks worse. Okay, good. So it's supposed to be a little side note about, hey, you can kind of mess with the formula if you want to, but we're not going to make that some formula we suddenly have to memorize, right? It's not more useful, really. Okay. Anything else from homework stuff?
65 was your point.
This dude. All right. Oh God, got all kinds of stuff.
Yeah.
Okay. We talked about this one a bit, so I want to find the area of this shape, right? What two shapes is that area comprised of?
Circle and right triangle.
Well, like a slice of a circle?
Yeah.
And a right triangle. Could you find the area of this right triangle?
Yeah.
Good. So then I got part of the area figured out already. I just have to add to that the area of this. And this is, again, this is a sector of a circle, correct? To figure out its area, what do I need to know?
Formula for area of a sector.
Yeah. So 1/2.
Flowers.
Good.
Trade-offs.
Do I know theta?
Yeah.
Sort of, right? Just have to change it to radians, correct? Do I know r? No, but
Pythagorean.
would you agree with me? That's the center, so either one of these sides is r?
Yeah.
Everybody agree?
Yeah.
Isn't this side, so this side is r, correct?
Yeah.
Can you figure out what that is?
Yeah.
Yeah, it's part of a right triangle, right?
Pythagorean theorem.
Pythagorean theorem, yeah. So the reason this problem is hard is because it's a few easy problems slammed together, right? So in general, I always feel like I was lucky with math because I naturally break problems down. I'm not better at anything. If you can draw really well, I can't see what somebody is composed of. So to be able to draw, you have to see the ovals and you have to see, I can't see that shit. I wasn't born with that, right? I was born with this natural ability to kind of break things down. That's why I was good at math, I think. That's what I think. I don't know. So when I see this kind of problem, I need to break it down into its parts. I've got it. This guy I know, fantastic. This guy, what do I need to know? Angle, okay, I can work with that. Radius, oh shit, okay, there's a radius. Oh, wait a minute, that's part of the triangle. So I'm kind of breaking it down as I go. The area of the triangle, easy problem. The hypotenuse, easy problem. Shoving stuff into the formula, easy problem, right? So there's 3 easy problems. Together makes it weird. You just have to know how to break it down. Now, in a lot of area problems, it's going to be breaking it down into, are there parts that I know formulas for, right? So if I want to know the area of house with a roof that looks like this, it's a really silly example, or shape like, not a house, but like a shape like this. This is a square, this is a triangle, I just need to know the right sides and I can figure out, right? But I don't have a formula for that area of that shape. There isn't one. I can break it into parts that I do know, and then add them together, right? Okay. That's what this problem really is. Break it into a triangle, break it to a sector. Now focus on each one separately, right? If you break it down into parts, every part is much easier. Okay, maybe. Okay. Anything else? Yes?
Hey, was it on homework? Could you go over 66?
Oh, here. Let's see if there was a reason I didn't sign it. Statute mile, 1 mile is 50 acres, nautical mile. Yeah, nautical mile is fun in the arc. So of course, nautical mile, considering the fact that we're kind of going on the surface of something curved, and if I'm going across the ocean, I very likely am not gonna, I'm gonna go far enough where the curve comes into play, correct? So if I went straight through the earth, if I swam through the ocean, that would be a very different length than if I went along the curve of the earth, correct? And most boats, you don't want them to go under the water, right? Speed boats, some kind of submarine. Blah, blah, blah. The arc length along the equation intercepted by a central angle. Yeah. I don't think I signed this one because the wording gets all really crazy. So basically, 1 minute slice of the earth, 1 minute slice of the earth, this arc length would be 1 nautical mile. You with me so far? So part of this problem is interpreting all the jargon they're using. You with me? Which is probably a reason I didn't want to sign this one. If the radius of the earth is 3,963 miles, right? Use the arc length formula to approximate the number. Yeah. So now it's just a arc length formula, right? So you've got the radius, you've got the angle. Now you got to change 1 minute into radians. So I'd change it into degrees first, and then change it into radians. And then you just throw it into S equals R theta. Again, that's not part of the homework. So if you're out there going, I don't remember that one. Yeah, okay. Yeah.
We could just do that. Why would they tell us about a nautical mile?
Huh?
Where does the nautical mile
No.
thing
This
come in?
is 1 nautical mile. If I do S equals R theta with the radius in miles, I'm going to figure out how long this is in miles. So we're going to figure out a conversion between nautical miles and everyday miles, or statute miles. All right, I'm not going to spend more time on it because I didn't decide that. Okay. Anything else from homework stuff? Yes.
3-3, number 78. Confused about the boundaries. Does that mean, is that another way of saying the whole circle? When you go negative pi?
No. So help me out. Negative pi.
Just go through
Where is that?
That's a quad 3 and 4.
It's not in the quadrant, right? Where's negative pi?
I thought it was somewhere.
Oh, shit. Sorry? Where's negative pi? Yeah, so it's the negative x-axis. Is that cool? That's a nice quick way to say pi. Where is it? Negative x-axis. Negative pi, sorry. And where's pi?
Awesome.
Positive x-axis. So it is the whole circle. Yes. Just later this semester, we're going to learn about... So real quick, looking at number 73 real quick. Do you understand what that's asking you?
Yeah.
Do you see how you have to think backwards? What angle would you take the sine of to get negative rad 3 over 2? Don't worry about the negative for a moment. How do you get rad 3 out of 2?
60.
Over 2 out of sine.
Sine
60. Is everybody cool with that?
Yeah.
If it's close to the y-axis, it's bigger. You with me? What quadrant does it have to be in to make it negative? In fact, we're in radians, so being more specific, 60 degrees is how many radians?
Pi over 3.
Pi over 3. Is everybody with me still? So again, how do I make sine become rad 3 over 2?
60.
Pi over 3. Right? Now I worry about the negative. All the negative is going to tell me is which quadrant I'm in. Which quadrants is sine negative? Third and fourth. Sine y-axis, third and fourth is where it's negative. Are you guys still with me? By the way, if I say, are you with me, and everybody is not saying a word, that doesn't mean that everybody is with me.
You want us to synchronize a yes?
Sorry?
You want us to synchronize a yes?
Synchronize, yes?
Come on, everyone on 3. 1, 2, 3. Yes.
Yes.
Okay.
What is
So the bigger point I'm trying to make, I appreciate that. The bigger point I'm trying to make is very often how the student come to me and say, I'm like the only person here not getting this stuff. And I'm like, if you're looking around at other people and other people are going like this, that doesn't mean shit. For some reason, and I've been teaching for a long time, for some reason people do not want me to know they don't understand something. And I'm like, I am the most immediate person that can help you if you don't understand something. So do not hesitate to ask questions. If I'm like, do you understand that? And you're like, nope, but you're keeping it inside. It's not good. You could be the hero for other people that are like, I don't want to say anything. So, assuming everybody's good. Yes.
So with number 8, it's kind of similar to 75.
Real quick, did we finish this one?
No.
What? So pi over 3 is the reference angle. You guys agree with me? Because that's what makes sine rad 3 over 2.
Yeah.
I'm going to be in the third and fourth quadrants, which means I could draw a little picture for myself. I'm pi over 3 past there, and I'm pi over 3 before there. Is that cool?
Yeah.
So what angle is this? What's pi over 3 past the full pi?
4 pi.
4 pi over 3. Yeah, it's a third of a pi more than a full pi, right? Become a 3. What's pi over 3 before 2 pi?
5.
Remembering that 2 pi is 6 pi over 3, that's going to be 5 pi over 3. So that's going to be, those are the answers to this because they live in this interval. Let me stop. What's up?
I'm not getting it.
So, okay. Everyone in here, at this point, I am going to assume that if I said, what's the sine of 60 degrees, you would definitely know that it's. If I said, what's the sine of pi over 3, you might have to think for a second, make it 60, and then you immediately know what that shit is, right? Okay. So all this question is asking you to do is to think backwards. So let me give you another question. I want the cosine of the angle to be, you can do it, Jeff, -1. No, negative, yeah, let's do this. Negative rad 2 over 2. So, reference angles kick so much ass because they allow me to only memorize first quadrant stuff, right? We know what angle makes cosine become rad 2 over 2, right? Ignore the negative for a minute. That's going to involve the quadrant. You all with me? So what angle makes cosine rad 2 over 2?
45.
Yeah, what is that in radians?
Pi over 4.
That's the reference angle, because I'm supposed to get negative rad 2 over 2, right? Now where is cosine negative?
2 and 3.
Yes, and by this point, you all know cosine likes x, SOHCAHTOA sucks ass. Cosine likes x, that helps me so much more. I know I must be the second and the third because that's where x is negative. My reference angle is what again? We did the work, pi over 4. So my reference angle is pi over 4. What angle is, what's the answers then? What angle is this? I'm 1/4 of a pi short of a full pi.
3/4 pi.
Sounds like a good description of me. 3 pi over 4. And now I go 1/4 of a pi past a full pi. 5 pi over 4. I like it. That's a really good example of what I was saying earlier. This problem, these kind of problems, involve multiple steps. Each step is not difficult. If I told you to take out a sheet of paper, did a pop quiz, and I said, what angle do you take the tangent of to get 1? You should all be able to tell me at least one answer, right? What angle do you take tangent of to get 1?
45.
45 degrees, that would work. If I said it has to be in radians, pi over 4. If I said I want it to be anywhere in the whole unit circle, pi over 4 is just one answer. Where else is tangent positive?
Quad 3.
Quad 3. So I'd have a pi over 4 reference angle down here. It again would be 5 pi over 4. Are you guys kind of with me?
Yeah.
Each step of that problem is relatively easy. The entire problem seems hard because it requires multiple steps, right?
So are you saying requires you to understand the unit circle and reference angle for the degree for the rad?
So again, if right now you're still kind of translating, you're fine. If you're still thinking like 60 would be 180 divided by 3, that's pi over 3, right? If you're doing that in your head, you're fine. You just need to be moving in the direction of, if I say pi over 6, you know it's 30 degrees. You just know it. Does that make sense? Okay. We're just not used to radians. How much of you guys work with radians? Some of you guys, a few days. Some of you guys have done radians before, so hopefully they make a little more sense, but okay. Yes?
Yeah, I was about to say, the way I was thinking, like how to convert to radians is like pi is the same thing as 180.
Totally.
So then 180 divided by 3 would be 60, or
Yeah.
180 divided by
4 is not as easy to do in your head, but yeah. You'll start to memorize that pi over 4 is 45. Pi over 3 and pi over 6 are kick-ass, because 180 is divisible by 6 and 3 easy.
or like 45 times 2 is 90, and then or like 4
Yeah,
five,
squat 2
4
45s
times.
is 90, 2 90s is 180, so 4 45s is 180. That's why it's pi over 4 kick-ass.
Yeah.
I love it. Okay. Whatever the hell way, get it up there. You guys with me? Because on this quiz, I will ask you something like, what is the tangent of 7 pi over 6? And you have to kind of like attack it, right? I'm going to ask for reference angle work. You can make it degrees if you need to.
So
You guys kind of with me?
So like with number 78, is it still like a full circle?
Yes, it is still a full circle.
Gotcha.
What they're doing here is, I need it to be, how do I want to say this? I I can't get an answer like 7 pi over 6. Do you guys see why my answer cannot be 7 pi over 6?
It's not in.
It's not in here.
Alright.
So if my answer is 7 pi over 6, I'm not saying it is. I have to actually answer it like this. 7 pi over 6, what is this angle? Negative something. 7 pi over 6 is pi over 6 past pi, correct?
Yeah.
So this must be 1/6 of a pi short of pi, going backwards, right? 5 pi over 6. What do you notice about 7 pi over 6 plus 5 pi over 6? Equals 2 pi, and it makes sense. This angle plus this angle has to make the complete circle, yes? And how many radians in a complete circle? 2 pi. So if you understand what I just said, if I know 7 pi over 6 forward, it must be the leftover 5 pi over 6, negative 5 pi over 6 to go backwards. Because together, I've gone around the whole damn circle. Yes?
So for questions like that, where you can get like a multiple answers, would you put multiple or would you just put one?
So that's why it says find the exact values. Because for example, 78 is going to have 4 answers. Just to warn you. Because again, what's the first step in 78? And when I take the square root, what happens to here?
Plus or minus.
Plus or minus, right? What's the square root of 1? Holy shit. What's the square root of 2? I don't know. If you rationalize that, you get this. Does that look like a familiar number? You know the angle I'm talking about? And since it can be plus or minus, it could actually be in any quadrant.
Is that because it's plus or minus, or because
Because
the
it's plus or
boundaries?
minus. Yeah. Well, the fact that they're asking me for the full circle, in a weird way, but still, then I care that it's in all 4 quadrants that it could be, right? We're sign positive.
First and second.
First and second, we're sign negative.
Third
Third and fourth. And this says sine equals plus or minus, that's all freaking 4 quadrants, correct?
Okay.
I like it. Hey, Mikey. Yes?
So for these problems, I just wanna, you said that there's multiple steps, I just wanna make sure I'm getting the steps right. So first you want us to, so of course you want us to understand the unit circle.
Yep.
Degrees. Then you want us to know the reference angle in degrees, and then translate that to radians.
The first 2 things you said are the same. So if you understand the first quadrant, you can get the angle in the first quadrant. That is the reference angle.
Okay.
Is that cool? How do we memorize all of the angles all the way around? Did we do it all the way around?
No.
We just did first quadrant. So if I think backwards, I'm going to get a first quadrant answer. That's the reference angle. And then I just got to put it in the right quadrant.
Okay.
And how do I do that? So again, like we just did, if, let's see, looking at number 74 real quick, what angle makes cosine 1/2? 60 degrees, which is how many radians? Pi over 3. So pi over 3 makes cosine 1/2. Now I worry about the negative. I got the angle in the first quadrant. First quadrant angles are reference angles, right? Now I just got to make sure they end up in the right quadrants. Where's cosine negative?
2.
Yeah, so how do I get in the second quadrant? I would go pi over 3 before pi. So what's 1/3 of a pi before pi? 2 pi over 3. Bam! There's one answer. Okay. And the other answer is going to be in the third quadrant. Does that make sense? Okay. Good. This is what I mean. So please, dear God, when I say does everybody understand, that's not me saying, all right, it's enough. That's me actually asking, do you understand? And if you don't, I'll further explain. It's crazy. It's like my job and shit. So, all right. Part of my job is also making sure we stay on pace. So never self-censor. If you're like, I don't want to ask because he's already spent a lot of time, I don't care. Ask me. And I'll say, see me after class. And that's what I'm going to do right now. If there's many more questions, see me after class. Because we got to keep going. Okay. Real quick, any follow-up on that? Everybody cool with that? Or cooler, I guess I should say. Does it make any more sense what they're asking there? Okay. And it's kind of like a standard thing we do in mathematics. To really make sure you get the idea of something, we do it backwards and forwards. So if I said, what's the cosine of pi over 4? You should be able to figure it out. If I said, what do you take the cosine of to get rad 2 over 2? Should be able to figure that one out. Opposite things, yes? Same ideas, just applied in opposite directions. Does it make any sense?
Yeah.
Okay. Knowing something backwards and forwards. That's different. Yeah. All right, so last time we got into graphing trig functions. And it kind of makes sense. You guys remember in algebra, every time you learned a new function, one of the first things you did was, how does it look when you graph it? You guys all with me? All right. So we've done a lot of shit with trig, so we're going to finally look and say, what the hell do these things look like if I graph them? So we already did some work last time. I had paper somewhere. Are you paper? Your paper. Yes. Okay. All right.
So are we still on chapter 3.3 or we're on new chapter?
We are in 4. We've been in 4, yeah.
Oh, okay.
Yeah. So we started 4 last time. 4 is the one where we're graphing. We did a little bit of sine wave stuff, right?
So like 4.2?
4.1 right now. Yeah. Okay. And yeah, I always do that. I know ideas. I very often don't know where the hell I am in the book. I understand from a student's perspective, you're like, I want to know where the hell we are, and I might go, I have no idea. I got to look it up. But just, always ask me, where the hell are we? All right. So last time we actually figured out what this looks like, right? And somebody tell me one of the most important things about this is, where does it start at 0? Yeah, so sine of 0 is 0. What's the biggest I can expect to get out of this? 1. Smallest.
-1.
Okay, so we knew all that stuff before we started graphing this, right? When does it hit 1? What input does it hit 1 at?
Pi over 2.
Yeah, sine of pi over 2 is 1. Somebody else tell me, when does it hit 0 again? Pi. I love it. And then, of course, at 3 pi over 2, what's it going to be at 3 pi over 2? Careful. Where's 3 pi over 2? It is here. Sine likes y, so it's going to be negative 1. And of course, at 2 pi, it's back on the x-axis. Sine don't like that shit. Oh shit. So it's going to be there. Let me stop for a minute. So do you guys get the feel we're moving a little bit away from right triangles? Sine is still the ratio of sides in a right triangle. But I can plot the outputs for the sine. It still is always, and always will be, the ratios of sides of right triangles. Always. But now we're just kind of plotting the output, and we're noticing something. If I keep going forward, what's it going to do? Because here I'm back to 0 degrees, or 0 radians, aren't I? I got back to the beginning. So of course it's just going to repeat the same damn shape, and then back here it's going to repeat the same damn shape forever. Right? This is one reason why it's called periodic. It's got a period to it. A period is officially the amount of time it takes for it to complete one cycle, and the cycle is all of the possible outputs have been achieved. My God. So how long does it take for it to reach all of its possible outputs? 2 pi. Or all of its possible locations would be 2 pi, and then it repeats that same shape again. So the one cycle is here, and that fits in 2 pi, so the period is 2 pi. It takes it 2 pi in order to go through its complete cycle. I like it. You would, Jeff, yes.
So when we're dealing with sine and all that in circles, and you said it was the ratio of sides between right triangles, we're basically
Ratio
forming-
sides of the right triangle, yeah.
Yeah, so we're forming like right triangles inside the circle, like when we're
In the
forming-
circle, sure. Yeah. And of course, so this idea is just the idea of, if I drew a triangle here, this would be the sine, correct?
Yeah.
If it was a unit circle, are you guys with me? Because sine likes y.
Mhm.
And as I go around, I can do similar things. And as I go around, I can do similar things. And as I go around, I can do I can do similar things until I get back in here. So it repeats. It creates the same triangles again. Which is why this graph makes sense. It's going to keep repeating its outputs because I just keep getting back to the beginning, creating the same triangles forever. Okay. I like it. So, a couple things we could do. We also talked about the midline. Can somebody describe where the midline is?
I?
Sorry?
I?
No. Is there a line that it looks like this thing is oscillating around? Say again?
X-axis?
Yeah, the x-axis. Do you guys see? Doesn't it look like it's oscillating around the x-axis? It gets away from the axis, and it comes back to it. It gets away from the x-axis, it comes back to it. Isn't it oscillating around the x-axis? Literally, it's the line that goes down the middle of the picture. That's why we, math geniuses, we went, let's call that midline.
Horizontally or vertically?
Vertically wouldn't make any sense.
Okay.
Horizontally, it's the middle of the picture. Yeah, okay. So the midline in this case would be the x-axis. Does anyone know, this could be a very strange question, the equation for the x-axis? Give me a point, any point that's on the x-axis.
Y equals 0. 0, 2. 1, 2.
Let's try some.
2, 0.
2, 0, I like it. Give me another point that's on the x-axis.
5,
5, 0. Give me another one. Negative 5, 0. So what's always true about any point on the x-axis? Y is 0. That's the equation of the x-axis. Y equals 0. You guys with me? Okay. That was weird. Was that intended? What is that? So the midline, you could also say it's y equals 0. You guys all with me? Okay. All right. Now, if I do one little thing, let's see if you guys are cool. In fact, let me do it right here. If I wanted to plot g of x equals sine x plus 1, what would that do to this picture? Yeah, it would take all the outputs I did get already, and it would increase each output by 1. So that would just be a shift up 1. I like it. So that one's pretty straightforward. When there's a number outside of the sign, plus 1, minus 2, whatever, it's just going to move it up or down. Where's the midline going to be now? Yeah, so if I shift it up 1, the midline's going to be here, and then it's going to oscillate around that midline. So you could literally just take this up by 1, take this up by 1, take this up by 1, and you can just redraw the picture. Is that cool? So a shift up and down kicks a lot of ass, because all it's going to do is every point, you just move it up or down, whatever it is. So if I put minus 3 instead of plus 1, if I put minus 3, you would take every point, move it down 3. Where would the midline be then? Y equals negative 3. Is everybody with me? Midline starts at y equals 0. If I move it up 1, it's at y equals 1. If I move it down 3, it's at y equals negative 3. Okay. Yes?
How do we move it right or left?
Let's talk about that right now. Okay. So in order to talk about that, I want to do a function we already know really well. Please tell me everybody's cool with that function right there. Right? Some of you guys are like, yeah, can we do that? No. Too early. We're just going to use it right now to investigate exactly what you just said. All right, math boy, how do I make that move left and right? So can you guys very quickly draw me a decent little sketch of that? And what I mean by that is, no, give me some points. Make a decent little sketch, right? Don't have your calculator do it for you. I said, you make a sketch. I didn't say you push buttons. One time I had a student, I got to tell you this real quick. One time I had a student, I told him to meet me in my office because his homework was copied. And he said, no, Mr. Waller, I Googled that. Do you understand what I'm saying? He did not get that does not equate to work. He Googled it, someone had posted the answers from the solution manual, and he copied it. And he literally thought that was work. He thought that was him working. You guys kind of with me? Anyway, a little insight into what teachers have to do. So it goes through 0, 0, right? So I just use -1, 0, 1 all the time. What's -1 go to?
1.
Good. What's 1 go to? Holy shit. And of course, we all should know it's got the little U-shaped dude, right? Now, what would happen if I did this here?
You would shift to the left or the right.
So a lot of you guys know about shifts already, which is cool. So maybe, hopefully, most of you guys have taken like college algebra already. Because otherwise, if you take college algebra after this, your algebra leaks out your brain. There's not like a ton of algebra in trig. There's some. But if you take trig and then you take college algebra, your algebra's leaking. It's not good. Okay. So you've probably already done like shifting, and you do like reflections and shifts up and down and so forth. And you can do compressions and stretches and shit, right?
Yeah.
All right. For the rest of you who haven't done it yet,
Too bad.
be happy he's not your teacher. What do I have to put into F? What do I put into F to have the output be 0? 0. You guys with me? So I put 0 into F to have the output be 0. What do I have to put into G so the output is 0? -1. Every input into G has to be 1 less than it was before, because the first thing G does is it gives it 1. It's sort of like if it costs $10 to get into a bar and like the cover charge, and there's a guy at the door that I know is going to give me $1. Can't I walk up there with 1 less dollar than I need because he's going to freaking give me $1 first thing? You guys kind of with me? Don't get too excited. I don't think that happens. Right? If I won the lottery, I might do that. So that's why a lot of students have trouble with this. They're like, but it says +1. Why am I going left 1 then? Because all my inputs can be 1 less than they used to be to have the same output. So this is literally going to just take it left 1. Every point, I can just, in fact, I'll do it up here. Every point I can just move back 1, back 1, back 1. And then I can just redraw a picture. So everybody's semi with me. Okay, so can you guys give me a decent sine x curve? Can you guys graph a decent sine x curve? And I'll give you this here. We'll just focus on this side for now. You can do it, Jeff. There you go, buddy. Put one little dude back there. There we go. Just give me a sine x curve. So it starts at 0, right? Then it goes up, down, down, up. And it's probably, and then it also, if you want to, it's going to go down here. Is that cool? Because negative pi over 2 would be the negative y-axis, so it's going to be -1. Does that make sense? So it's going to look like that, and like this, like that. Like this. Okay. Alright, so what in the hell would this do? You can do it, Jeff.
Left 5 over 2.
So every point is going to move left pi over 2. So you can literally just take that point, back pi over 2, that point, back pi over 2. And then you just redraw it. Alright? Whee! And that's kind of cool. You can see it looks like a shadow, like a reflection on itself. Yeah.
The one thing I never understood is when they're shifting, why did they make, when you're going positive, you're moving into the negatives?
So again, that's the whole thing I just said. what's the very first thing I do in this function to any input? What's the very first thing this function does? Any number I put here was the very first thing that happens to it.
Plus pi.
I add pi over 2, correct? So every input I put in can be pi over 2 smaller than it used to be to get the same outputs. Does that make sense? So literally, that's all that happens. So the shortcut is, when it's inside with the variable, it does the opposite of what it looks like. When it's outside, so if I had put this, what would that do? It would take that, those outputs, and it would increase them by 1. So when it's outside, it does exactly what it looks like. When it's inside with the variable, it does the opposite of what it looks like. And just to show you, real quick, watch. F of x, what the shit used to be there before we brought function notation in?
Why?
Y. Alright, the pi over 2 is with the x, correct?
Yeah.
It's positive, so I'm actually going to move left pi over 2, because like Jeff just said, you do the opposite of what it looks like. If I move this over with the y, is that number now with the y?
Yeah.
So since it's with the y, it'll do the opposite of what it looks like. It would go up on the y-axis. Do you guys see that? Do you actually, now real quick, am I telling you you should do this?
No.
Shit, no. But I'm trying to show you why it seems like different things happen, because that's not with its variable. That's why it does exactly what it looks like. That is with its variable, it does the opposite of what it looks like. Does that make a little more sense? So for those of you who talked about transformations before, I have no idea what your teacher showed you about it. Right? But that is why that happens. So if I would have put a minus inside, the whole thing would have shifted which way?
Right one.
Right, whatever, right? Maybe. Yes.
You might have just said this, but like, and this is a refresher for me. So, we'll say x plus pi over 2, it would not be to the right.
Right now, no, just like we did, we went left. Correct?
Yeah.
Again, why does that make sense? Am I not plotting points related to inputs, right? When I plot a point, the input here would be negative pi over 2, for example, yes? Okay. My inputs can be pi over 2 smaller than they used to be, because the very first thing it's doing to me is it's giving me pi over 2. So before I had to be 0 to get 0. Now it could be pi over 2 smaller than that to still get 0, because the first thing it's doing is giving me pi over 2. What do I get when I put a negative pi over 2 right here? What do I get? Negative pi over 2 plus pi over 2?
Sine is
0.
0.
So 0. Do you have to do that? No. You just have to internalize. When it's with the variable, it does the opposite of what it looks like. Why? Because that's allowing my input, in this case, to have pi over 2 less. If I put minus pi over 2, if there's a guy at the door that's going to steal $2 from me, and the cost is $10 to get in, I better come to the door with how much money at least? $12. Of course, I want some more, so I should drink that. Just to get in the damn door, aren't I going to have $2 more than normal if there's always some guy, very strangely polite mutter, I just need $2 to give it to me. Thank you so much. Doesn't take all my money. So I have to come to the door with $12 then. Is that cool? So if I do minus, my inputs have to be bigger to overcome that subtraction. Yes?
It depends if you ask for statement.
Oh, okay. Gotcha. I'm not sure how to work that into this. But yes?
Or you can just come to the door with $10 and if that mugger tries to steal something from you, still.
Oh, sure. Okay, so if you can get a hold of the sign and snap it a few times, show me that. That'd be weird. But I just want to see that. Jeff, it's signed. Look. And then I'll let you do different stuff. Okay.
Does the polite robber have a knife, or does it just ask us for
I
money?
want to be very, very quiet when you go there.
Good day, sir. Might I acquire $2?
Yes, he's. I'm not sure why polite has the British. Can't be American. We're not polite. Okay. I like that. All right. We did talk, if I remember correctly, we did talk about cosine a little bit. What's the main difference between sine and cosine? Do they actually look the same?
Yeah.
They do.
Yeah.
They look exactly the same. Just cosine is going to start where at 0? At 1. Yeah. Because cosine of 0 is 1. So, but it still has the exact same shape as sine. I'm not even going to be very specific there, right? You guys all with me? Okay. So if I give you a cosine function that's been shifted, you start with this and then you move it around. So let's talk about some more stuff. So for example, real quick, if I had, if my function was cosine of x minus pi plus 2. Oops. Can you list the shifts? What are the, how would this move?
Right pi
Right pi
and up to.
So I just take every point, right pi, up to. Right? You guys semi with me? So this is what I'm going to want from, well, I'll show you what I'm going to want from you. So when you do the transformations in college algebra, you list them, you do them. With trig functions, some of these have specific names. And I have a nice couple of shortcuts to kind of get to the answer more quickly. Imagine this. Imagine if I wanted us to move this by pi over 3. Do you understand how that would be very difficult? Just to show you guys, this is pi over 2 here, right?
Yeah.
And then I've got pi, and eventually it's going to get to 3 pi over 2, and eventually it's going to get to 2 pi. Okay. Yes?
Would I be more down if I don't like the word units?
Units?
Like I had a professor that marked me down when I didn't put like the word units after.
Did I put the word units? No, I'm sorry. I'm not being mean, but I'm just saying, did I put the word units? No. I don't need that shit. Yeah, I'm sorry. Up to, I know what that means. Right? There's no functional difference between up to and up to units. I'm with you. Okay.
Yeah, I think that's an algebra thing.
Well,
Shifting up 2 units or right, however many units.
yeah, I don't care. I teach pre-calculus. I don't make them write units because we know what it means. Yeah, okay. Can everybody understand if this was the thing? Do you see how difficult this would be to do here? Why is a movement of pi easy? Because I already have my scale kind of in terms of pi, correct?
Yeah.
Could you move this right pi over 3 easily?
Not really.
The first one would be easy. If I go right pi over 3 from 0, it's pi over 3. But then this would be a little gross. Do you guys kind of understand what's happening? Okay. So I'm going to have a nice shortcut method. So I can kind of incorporate all the transformations at once to see how it's going to look at the end. I don't know if that sounds good or bad to you. We're going to find out. Another transformation is a very simple one that I'm surprised I haven't done yet. So very quickly, cosine x, let's draw a semi-decent sketch of that. Leave some room, you'll see why in a minute. So this will be, it starts off at 1, we'll make that 1. And then it goes, and this is pi over 2, and then it goes pi, and then it goes 3 pi over 2, and then it goes 2 pi. Oh, pi. You guys all with me? So back here it would go back to 0 at negative pi over 2. Just because. We are. Okay, whoa, shit. So what would this do? Let me do 2 things at once. No, yeah, let me do 2 things at once. What would that do? Good. The negative would flip it.
It gets deeper.
Now you ready for this?
Would it get like elongated or?
Not yet. Not this way. All right, couple things. If it's inside with the x, that's left and right. If it's outside, it's up and down, correct? You with me? This 2 is outside, correct? So it's just going to make it 2 bigger out here. You with me?
Yeah.
The negative, so can you find all the old outputs here? Yes, there they are. They're right there. There's the old outputs, yes? Do you see what I mean by that? Didn't I find cosine again? So the quick way to kind of look at this is what am I going to do to every output? I'm going to take every output and multiply by -2. So the output here was 1. What's the new output for g of x going to be? -2. So it makes the, what do we call that for a wave? When I increase this, I'm increasing the what? When you hook a guitar up and you want it to be louder, what do you put it into? Amplifier, right? And we call it an amplifier because it actually makes the tude bigger. So the number that's in front of our trig function is the amplitude. And all it really is, it just multiplies the outputs by something, right? So if I wanted to be a smaller amplitude, I would just put a fraction out front. Does it make sense? I could cut the sucker in half and smoosh it. So the official name of what we're doing right now is it's a vertical stretch. Do I care about official names that much? No, right? It changes the amplitude. That's what I care about. Right? Let me ask you a weird question. What's the amplitude of the original? I guess it's not too weird. What's the amplitude of the original? Good. Not 2. Do you see why somebody might think the original has an amplitude of 2? The amplitude is officially how far do I get from the midline. So the amplitude of the original is 1. What's the amplitude of the new thing? Careful. 2. Good. Not negative. It doesn't get negative away from something. Negative would mean you're like inside or something. It is 2 away. It just reflects. Right? So the amplitude here is 2. Yes?
Suppose for whatever weird reason that it only goes up to +2 but -3. Would the amplitude be 2 or 3?
Could never, well, okay. If it did that, quick side note. If it went up to 2 and down to -3, where's the midline?
-0.5.
Yeah, so if you add -3 and 2 and divide by 2, you'll get the midline. Like the midline is really just the average of those two, so it'd be -0.5. So the amplitude then would be 2.5. 2.5 above -0.5 is 2. 2.5 below -0.5 is -3. Does that make sense? You can't ever have like a, well, I don't want to say that because you can make a lot funkier functions that do weird ass shit. But for the ones we're going to look at, we can never have something that's different in this direction than it is in that direction. We're not going to have like, no, it's going to have same amplitude around the midline. Yes? You guys kind of with me?
There's some weird looking graphs out there.
By the way, when you pluck a guitar string, thank God what happens eventually. You pluck it and then leave it alone. Eventually it's going to die out. So what's the sound wave doing? Is it getting smaller and smaller? So the formula for a dampened oscillation, right, for something that's getting smaller and smaller, has to have somehow an amplitude that's changing. So if I put an x in front of cosine, for example, wouldn't the amplitude be different as I move along? Do you guys see what I'm saying? If I put an x in front, the amplitude at 1 would be 1. The amplitude at 3 would be 3. Does that make sense? If x is 3, there would be 3. If x is 4, there would be 4. So in that case, the amplitude is getting way bigger over time, yes?
Yeah.
All right, went a little farther than I needed to.
So
We're just going to deal with constant amplitudes, yes?
So if the amplitude is -1, would it just be sine?
Amplitude cannot be -1.
Oh, okay.
Amplitude is a distance away from the middle, and you
Yeah.
can't have a negative distance.
So like the coefficient.
You are 3 feet away from me, I don't care if I turn around.
Yeah.
If you're negative 3 feet away from me, you're like, you're in me.
Yeah. But like if the coefficient was -1.
Huh?
Vision of body snatchers stuff.
Yeah. Or more, or, what was I just thinking? I think I just got, I can't remember the name of the movie.
The thing?
No. Yes.
Just want to ask real quickly, we're still in chapter 4.1 or?
Section 4.1.
Okay.
4.1 is about sine and cosine. Obviously, later sections are going to involve tangent, cotangent, cosecant, secant. 4.1 is just about sine, cosine. Okay. Somebody else? Yes.
Yeah, I think you're saying if the coefficient is -1, right?
If the coefficient is -1,
Yeah.
it's just going to flip this.
So it'd be sine.
That's all it would do is a flip. The amplitude would be 1. It doesn't become sine. If I flip this, it's just an upside down cosine. To make this become sine, I'd have to shift it and flip it, right? Because sine is supposed to start at 0. If I just make this -1, that's not sine.
Are most of the graphs we're just gonna be able to be respectful to the x-axis, or are we gonna go something like for the y-axis?
We're only going to focus on functions. Now, what does that mean? What's a function? You guys know? It's got to pass what test? Does anyone remember? To be a function, you have to pass the vertical line test. So if I had something that was going around the y-axis like this, is that officially a function? Are there any things that do this? Hell yeah. If I did x equals cosine y, that would do this shit. Are we going to do that in this class? No. But it would be the same. It would be exactly the same. I just have to do this. Yeah.
So if you put x in front of cosine, it would get the amplitude continually bigger, right? What if you put 1/2 in front of the x? That's also in front of the cosine.
Same thing. It'll just get bigger, slower.
Okay.
Yeah, but let's not talk about that too much. I'm sorry. Sorry about that. Okay. Now let's investigate something I think has come up a few times. I know we keep drawing sine. I don't care because it's good. So let's investigate what happens if I do this. It's inside with the x, correct? So you might look at that and say, oh, my inputs get twice as big now. But we know better. It's inside with the x. Does the opposite of what it looks like. So all my inputs are not going to get
Why is it small?
no, half as big, yeah, twice as long. So it's going to, if my input used to be pi over 2, now it's going to be pi over 4. So visually, it's just going to take the function, smoosh it. So let's see what this is. Let's see. All right. So my normal sine function, if I just graph sine x, so what I like to do with these is, well, for right now, we're going to graph the base function. What I mean by base function is it hasn't been shifted yet. So pi over 2, pi, just pi, Jeff. 3 pi over 2, 2 pi. So then I can do this, bam, 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 bam. And what I'll often do is I'll make my base function dotted because it's not the answer yet. Yeah. So that is sine x. So if I want to graph this, every input that used to have a certain output will now be half as big. So for example, it's a very strange thing. Pi used to give me an output of 0. If I cut that input in half, pi over 2 now gives me an output of 0. So it literally is me just going, right? So if I cut every input in half, this point gets cut in half. What's half of 0?
0.
Holy shit, so that stays right there. This used to be, so that's there. What's half of 3 pi over 2?
1.5 pi over 2.
Or better yet, 3 pi over 4, right? That's going to be in here, so that goes there. What's half of pi over 2?
5 over 4.
Pi over 4. Let me stop, make sure you guys are with me. An input of pi over 2 had an output of 1. Now it's going to be half. So an input of pi over 4 is going to have an output of 1. Here, this was, what did I just do, Jeff? 3 pi over 2 is now going to be 3 pi over 4. And 2 pi, cut that in half. 5. So now it's going to look like this. Is the period the same?
No. Wait. Yes.
Where is there a cycle? The cycle starts at 0 and goes until when is it done?
Oh, it's pi.
Pi. What did the period do?
Got smaller.
Cut in half. It makes sense. The period is all about how long it takes, and if I'm smushing it by a factor of 2, the period should get cut in half. If I wanted the period to be longer, what number would I put in there, for example, instead of 2? 1/2. That would make it twice as long. You guys kind of with me? So what's the period of the original sine function?
2 pi.
2 pi. What's the period of this guy? And how did we get that? 2 pi, and we cut that in half, because there was a 2 there, correct? If I would have put a 3 there, what would the period have become?
2 pi over
2 pi over 3. So whatever the hell number this is, I take the old period divided by that number. We stop for a minute.
So in this case, the period would just be pi then, right?
Exactly, because now I can fit an entire cycle in just the pi's worth of the x-axis. Does that make sense? And again, if I would have put a 1/2 in there, it would have taken 4 pi. So just by itself, can somebody tell me what the period is for this? What you got, Jeff? I don't know. Sure. 5, no, it's not going to make it too freaky yet. 5x.
2 pi over 5.
Yeah, the new period. It's going to be 2 pi, the old period divided by 5. Now, just thinking about graphing, do you agree that would be very strange to try to graph this? Okay. So again, I'm going to develop a process that sort of wraps all the transformations up into one single process. So you have to apply each thing separately. That's what can make this really horrible. Okay. Because where we're headed is I'm going to give us a function like this. Let me just show you my final form, okay? I'm going to give you something like this. Right now, based on what we've done, this would be horrific. I don't know if you guys agree with me.
Yeah.
So many things are happening here. Yes? First thing I want to say, we're not gonna do all that. I just want to show you what it's going to look like, and the process I'm going to show you is going to kind of make all the transformations happen at once. Very first thing I want to ask you is, how much would this move left or right? And I want to warn you, you can't tell the way it's written.
Pi over 3 to the right.
Yeah. So in general, how do I tell how much is going to move left or right? I look to see how much the x is changing by. Pi is being taken away from 3x. So if I take a 3 out, see how many people are freaked out by this. If I take a 3 out, I'll do the first thing. 3x divided by 3 is x. Yay, look at me go. I just kind of gave it away as to what goes here. And so did you, but hang on to that. What's going to go here and why?
Pi over 3.
Yeah, because again, if I take something out, I'm dividing it out. 3x divided by 3 is x. Pi divided by 3 is pi over 3. So now can I see exactly how much in which direction it's going to go? Left or right?
Right.
Right. How much? Pi over 3. The official name of a left and right motion for trig functions, you're going to love this shit. It's called phase shift. So we get amplitude for how much it's been stretched or smushed. We got phase shift for how much has been moved left or right. Are you guys with me? Okay. Then we got the period. Can anyone tell what the period of this is going to be? You can do it.
5 over 15? 2 pi over 15?
No. What's the amplitude going to be? 5. Good. What is the multiple of x? Remember, that's how I figured out the period? Multiple of x, I take the old period divided by it, right? What is x being multiplied by? What is x being multiplied by? 3. So what's the new period going to be? 2 pi over 3. We stop for a minute. Now, if I wanted to graph this the way we've been graphing other things, that would so desperately suck. Do you guys agree? Yeah, plus I'm all the time down. The last thing here is up to you, right? So next time what we're going to focus on is what the shit is this mysterious way to do this, Jeff? I'll show you. It's kind of nifty. It's going to make these a little bit easier because I'm not going to do that problem by applying every shift. That would drive me insane, right? So I'm not gonna make you do it either. So I'm gonna show you a nifty shortcut. Yeah.
Is it calculator?
Hell no. No shortcut for me is ever called calculator. Calculator is how you check your work. It is never how you do your work.
With the system.
Unless I say use the calculator to figure out cosine of 3. Yeah.
Aren't you able to put a period of 2 pi in your calculator?
Say again?
Aren't you able to put like a period of 2 pi in your calculator though? Like,
Yeah, I will show you how to graph stuff in your calculator so you can check your work. But you can make it do a trig scale. Is that what you're saying?
Yeah, I think it's like negative 6.28.
Well, no. You can actually push one button and it'll change everything to trig.
Show like, just like to like round it like negative 6.28.
Sure. But there's also a single button you can